Jupiter, the largest planet in our solar system, is more than just a gas giant. It acts as our cosmic guardian, shielding us from the dangers lurking in the depths of space. Its immense gravity acts as a cosmic vacuum cleaner, deflecting and capturing asteroids and comets that stray too close to Earth. Without Jupiter's protective presence, our planet would be a much more dangerous place. For billions of years, Jupiter has been a silent guardian, deflecting countless cosmic bullets aimed at our planet. This gas giant's gravitational influence is a key factor in the stability and habitability of our solar system. It's a testament to the interconnectedness of our cosmic neighborhood. Jupiter's gravitational pull is like an invisible hand, shaping the trajectories of celestial objects. Asteroids and comets, remnants from the early solar system, hurtle through space at incredible speeds. When these objects venture near Jupiter, its immense gravity can either fling them out of the solar system entirely or capture them in its orbit. These captured objects become part of Jupiter's vast collection of Trojan asteroids, trapped in a gravitational dance around the gas giant. This cosmic ballet, while mesmerizing, serves a crucial purpose: protecting the inner solar system, including Earth, from potential impacts. But what happens when our cosmic guardian fails? What if an asteroid, large enough to cause significant damage, were to slip past Jupiter's defenses and hurtle towards Earth? This is not just the stuff of science fiction. It's a real threat that has shaped our planet's history and could shape its future. While Jupiter provides significant protection, it's not foolproof. Asteroids can still be nudged onto Earth-crossing orbits by the gravitational influence of other planets or collisions within the asteroid belt. These rogue asteroids, no longer under Jupiter's control, pose a significant threat to life on Earth. The moment an asteroid, even one significantly smaller than those deflected by Jupiter, enters Earth's atmosphere, the sky would erupt in a fiery spectacle. The sheer speed and size of the asteroid would cause it to heat up dramatically, creating a brilliant light show that could be seen for miles around. The friction between the asteroid and the atmosphere would create a blazing trail, visible even in daylight. This blazing trail would be accompanied by a deafening roar as the asteroid tears through the sky, leaving a path of destruction in its wake. Upon impact, the energy released would be equivalent to thousands of nuclear weapons detonating simultaneously. The explosion would be so powerful that it would create a massive crater, sending debris and dust high into the atmosphere, blocking out the sun and plunging the Earth into darkness. The immediate aftermath would be catastrophic. The impact would cause widespread devastation, destroying cities and towns, and leaving a trail of destruction that would take years to recover from. A massive shockwave would radiate outward from the impact site, flattening everything in its path. Buildings would crumble, trees would be uprooted, and anything in the vicinity would be obliterated. Earthquakes of unprecedented magnitude would ripple across the planet, triggering volcanic eruptions and tsunamis that would dwarf anything in recorded history. These natural disasters would cause further destruction, compounding the already dire situation. The air would become superheated, igniting massive wildfires that would consume vast swaths of land. These fires would spread rapidly, fueled by the dry conditions created by the impact, and would be nearly impossible to control. In the long term, the impact would have profound effects on the global climate. The dust and debris thrown into the atmosphere would block out sunlight, leading to a dramatic drop in temperatures and potentially triggering a nuclear winter scenario. This would have devastating effects on agriculture, leading to food shortages and widespread famine. Both humans and animals would struggle to survive in the harsh conditions that follow. The loss of habitat, combined with the scarcity of food and clean water, would lead to a significant decline in populations, and the world would be forever changed by the event. Section 5. Size matters, a planetary perspective. The severity of the impact would depend on the size of the asteroid. A relatively small asteroid, say a few hundred feet across, could devastate a city or cause widespread damage if it landed in the ocean. However, an asteroid a mile wide or larger could have global consequences, potentially leading to a mass extinction event. To put this in perspective, the asteroid that wiped out the dinosaurs 66 million years ago is estimated to have been about 6 miles wide. That impact released the energy equivalent of billions of atomic bombs, causing widespread devastation and forever altering the course of life on Earth. Section 6. The extinction threshold. When life teeters on the brink. The very fabric of existence hangs in a delicate balance, and sometimes it only takes a single event to tip the scales. An impact of that magnitude would trigger a chain reaction of catastrophic events. The initial collision would release an unimaginable amount of energy, equivalent to millions of nuclear bombs detonating simultaneously. The massive amounts of dust and debris ejected into the atmosphere would block out the sun, plunging the planet into a state of perpetual darkness and cold. This phenomenon, known as an impact winter, would drastically alter the climate. This impact winter could last for years, disrupting plant life and collapsing food chains. Without sunlight, photosynthesis would cease, leading to the death of plants and the herbivores that depend on them. The impact would also release massive amounts of greenhouse gases into the atmosphere, leading to rapid and extreme climate change. These gases, including carbon dioxide and methane, would trap heat, causing temperatures to soar once the dust settled. These sudden and dramatic shifts in temperature and atmospheric composition would create a hostile environment for most life forms on Earth. The extreme cold, followed by intense heat, would challenge the survival of even the hardiest species. Only the most adaptable and resilient species would have a chance of survival. Evolution would take a brutal turn, favoring those who could withstand the harsh new conditions. In this new world, survival of the fittest would be the law of the land. Section 7. A world transformed, the long shadow of impact. The impact of a large asteroid would be a defining moment in Earth's history. The planet would be forever scarred, both physically and biologically. The impact crater itself would be a testament to the destructive power of these celestial objects. The long-term effects on Earth's climate, atmosphere, and ecosystems would be profound. The recovery process would be slow and arduous, taking thousands, if not millions of years. Life would eventually rebound, as it always has, but it would be a different world. The dominant species that emerged from the ashes would inherit a planet forever changed by the impact. Section 8. The darkness descends. Nuclear winter engulfs the Earth. One of the most devastating consequences of a large asteroid impact would be the onset of a nuclear winter. The impact would eject massive amounts of dust, soot, and other debris into the upper atmosphere, where it would circulate the globe and block out sunlight for months or even years. This perpetual darkness would have a catastrophic effect on the planet's ecosystems. Plants, the foundation of most food chains, would wither and die without sunlight. Herbivores would starve without their primary food source, and carnivores would soon follow. The once vibrant ecosystems would collapse, leaving behind a desolate and silent world. Section 9. From the ashes, life finds a way. Despite the apocalyptic scenario painted by an asteroid impact, it's important to remember that life on Earth is incredibly resilient. Life has endured multiple mass extinction events throughout Earth's history, each one reshaping the biosphere and paving the way for new species to evolve and thrive. While a large asteroid impact would undoubtedly cause widespread devastation, it would not necessarily spell the end of life on Earth. Extremophiles, organisms that thrive in extreme environments, would likely survive in the aftermath. Over time, these survivors would adapt to the changed conditions and evolve into new forms, eventually repopulating the planet. Section 10. Cosmic Threats. A reality check. The threat of an asteroid impact is not just science fiction, it's a real danger that we must be aware of and prepared for. Scientists estimate that there are millions of asteroids in our solar system, and while most pose no threat to Earth, there are still many that we haven't discovered or fully assessed. The good news is that we are not sitting ducks. Space agencies around the world are actively tracking potentially hazardous asteroids and developing technologies to deflect them if necessary. These efforts are our best defense against these cosmic threats. Section 11. Guardians of Earth, our planetary defense system. This system is a testament to human ingenuity and our collective will to protect our home. Protecting our planet from asteroid impacts is a global responsibility. It requires the combined efforts of nations, scientists, and engineers from around the world. International collaboration is crucial for sharing information, coordinating observations, and developing deflection strategies. Early detection is key. By pooling our resources and knowledge, we can create a more comprehensive defense system. The sooner we identify a potentially hazardous asteroid, the more time we have to develop and implement a plan to divert it. This early detection allows us to explore various deflection methods, from kinetic impactors to gravitational tractors. The future of life on Earth may depend on our ability to protect ourselves from these cosmic threats. Asteroids have the potential to cause mass extinctions, and our preparedness can make the difference between survival and catastrophe. By investing in research, technology, and international cooperation, we can become the guardians of our own planet. Advanced telescopes, space missions, and computer simulations are just a few of the tools at our disposal. It's a challenge we must rise to meet, for the sake of our planet and all life that calls it home. The stakes are high, but with determination and collaboration, we can ensure a safer future for generations to